All right, so when you're due now, it asks you how can you tell the vertex of a quadratic when it's in standard form? And hopefully you remember that means that you need to find your axis of symmetry. To find your axis of symmetry, and then use the value of your axis of symmetry to find your y of your vertex. So to the gist of that, and we're going to be using that this morning, today. So tomorrow is our STAR test tomorrow, which is our STAR Renaissance. It is just checking where you are mathematically, where your level's at. And then, so it counts as a daily grade. So it's a completion grade as long as you do it. And then next week we have our PSAT on Tuesday. I do have study guides. If you are remote and you want to come get one, just send me an email and I'll leave a copy in the front office for someone to pick up. Or you can, yeah, I think that's your only option. And then, yeah, so those are just kind of two big things I just wanted to highlight. So today, 528, graphing quadratic in standard form. So graphing quadratic in standard form, there are a couple steps that we're going to follow. But first we need to recall again the axis of what is the standard form. So standard form is our f of x equals ax squared plus bx plus c, and a cannot equal 0. Okay, it makes a parabola. The axis of symmetry is the line x equals negative b divided by 2a. So when you have your, pretend that this is like the best you've ever seen. Don't know why I'm writing sideways, but we're gonna go with it. Okay, so your axis of symmetry, and I have to draw a sideways axis of symmetry. I got this. Your axis of symmetry is the invisible line that would divide your parabola into two equal halves. On that axis of symmetry lies your vertex, correct? Hopefully remember that. And so when you're trying to find the vertex, the x coordinate of your vertex is the axis of symmetry. Okay, it is the value of your axis of symmetry. The y coordinate of the vertex is found by plugging in your x coordinate into the function, the equation, and then putting it together. And then your y-intercept is 0, your c value. Okay, so to find the axis of symmetry is step 1. Then we find the vertex, which is just basically finding your y value that's left, and then find the y-intercept. And then we graph the vertex, graph the y-intercept, and we're going to reflect it over the axis of symmetry. Okay. So those are the steps that we're going to follow. So first thing here, we have the function 2x squared minus 8x plus 5. And we're going to graph and then state what the domain and range are. So I have 2x squared minus 8x plus 5. The first thing I'm going to do is find my axis of symmetry. Right? And axis of symmetry is x equals negative b divided by 2a. So looking at what I have here, I have my a, my b, and my c. So my axis of symmetry is x equals negative 8 divided by 2 times 2. A negative times a negative is a positive. 2 times 2 is 4. 8 divided by 4 is 2. So my axis of symmetry is at x equals 2. Because that's where my axis of symmetry is. That means my vertex has to lie on it as well. Okay? So then the second part is to find my y coordinate of my vertex. To find the y coordinate of my vertex, I take what I got here and I'm going to substitute it into the function. So I'm going to find f of 2 equals 2 squared minus 8 times 2 plus 5. That equals 2 times 4 minus 16 plus 5 equals 8 minus 16 plus 5 equals -8 plus 5, which equals -3. So that's my y coordinate. I have my x, I have my y, which is -3. So my vertex is at 2, -3. So I'm going to go to 2, -3, and plot my vertex. Next is identify my y-intercept. And your y-intercept, remember, it's just 0, comma, your c value. And what is our c value? 5. So my y-intercept is 0, comma, 5. So I'm going to plot 0, comma, 5. It is 2 units from the axis of symmetry. So when I reflect on the right, it's going to be 2 units also from the axis of symmetry. I've now plotted. I'm now going to connect. Pretend that I went through that point. And there's my sketch of my graph. So the domain here. So my domain is from -infinity to +infinity, all real numbers, correct? Because it goes forever to the left and to the right. My range here, my range is from bottom to top. My lowest y value is -3, and I go on forever to infinity. So I have bracket -3 to infinity. Okay, I can also write this as y is greater than or equal to -3. How do we feel about graphing? Good? It's not terrible, right? It's a lot of little math that you already know put together. All right, so we're going to do another one. All right, so same thing here. I want you to either follow along, but I encourage you to work ahead. So I want you to try to do this, on your own. So as we're working it, if you can be a step ahead, that's awesome. But we're graphing f of x equals -3x squared plus 6x minus 9, and we want to know what is the range of this. So like we said before, the first thing you're looking at for your axis of symmetry. Okay, your axis of symmetry, again, is x equals -b divided by 2a. My a is -3, my b is 6, and my c is -9. So x equals -6 divided by 2 times -3. That gives me -6 divided by -6, which equals +1. So my axis of symmetry is at +1. Okay, remember your axis of symmetry is the x coordinate of your vertex. So I already have the x of my vertex. I just now need the y of my vertex. So to find the y coordinate, I am going to substitute in what I got, which is 1, into the equation. And I have -3 times 1 squared plus 6 times 1 minus 9. That gives me -3 plus 6 minus 9. That gives me 3 minus 9, which equals -6. So I have my x, I have my y. So my vertex is at 1, -6. Step 3 is to find your y-intercept. And remember, the y-intercept is just 0, comma, c. And what was our c value? -9. So we have 0, comma, -9. So I'm going to go over here to -9. And reflect it across the axis of symmetry. Does it make sense that our parabola is concave down? The answer is yes. Why does it make sense? Because our A value was negative. So that's why our parabola is concave down. Okay, it says, what is the range? So the range for this graph from bottom to top, to the bottom is heading towards negative infinity. To the top, my limit is -6. So from bottom to top, we have negative infinity to -6. It can also be written as y is less than or equal to -6. All right, are you ready to do one on your own? Okay, so here's yours. All right, so the first thing you have to do is find your vertex, right? I mean, find your axis of symmetry. Is it okay if I just write AS for axis of symmetry? And so to find that, I had x equals, and remember this is your A, your B, your C. So we have x equals -b, which is -8, over 2 times A, which is 2. And we end up with a negative times a negative is 8, positive. 2 times 2 is 4. 8 divided by 4 is 2. So that means we have for our vertex, we know that our x coordinate is 2, because that's our axis of symmetry, and our vertex lies on our axis of symmetry. Now we got to find the y coordinate, and y equals your axis of symmetry, the x value plugged in. So we have 2 times 2 squared minus 8 times 2 plus 1. That gives us 2 times 4 minus 16 plus 1 equals 8 minus 16 plus 1, which equals -8 plus 1, which equals -7. So the y coordinate is -7. 3, remember your y-intercept is just 0, your c value. And our c value is 1, so 0, 1. I'm going to graph and reflect. So I go to 2, -7, 0, 1, 2 units away from the axis of symmetry on the left. So I'm going to be 2 units away from the axis of symmetry on the right. And almost made it, y'all. And there is my graph. How do we feel? Easy peasy. All right, so on your classwork for today, you have you're going to, oh, we didn't say the range. I'm so sorry. The range, I have a concaved up parabola. So my range is going to be from -7 to positive infinity, or y is greater than or equal to -7. Okay, so on your classwork for today, which you are going to do the front 1 through 5. So you are doing numbers 1 through 5 on the classwork. And then on Friday, we're going to do the remaining 6 through 11. And that's that.
And it's all due Friday, right?